Okay, let's take a look at our mixture problems and let's see what we have here. In the first problem, we have a lab technician that needs to create 800 milliliters of 2% hydrochloric acid for an experiment. How much pure water does she need to mix with a 5% solution to create 800 milliliters of a 2% solution? So we are trying to create that's kind of thick. We are trying to create a 2% solution, and the volume is 800 milliliters. We have pure water, so over here we can say this is pure water. Now, if our concentration is measuring hydrochloric acid, we certainly hope that the water doesn't have any hydrochloric acid in it. So now over here we have a 5% hydrochloric acid. Okay. How much pure water? Let's let that be X milliliters. Now, this is the total amount that we have, 800. Now, if we remove all of the pure water, what's left is this 5% solution. So here's the volume that we have over here. If we add these two volumes together, we should get 800. So if this is X, this is 800 minus X. So if this is 10, then this is 790, and the 10 and the 790 add up to 800. Whatever this number X is, this is the rest of it, so that the total is 800. All right, now, so there's a picture, hopefully, of what I guess we would call these solutions. It's a 5% solution and a 2% solution, just to give them titles, because I have a title over here for pure water, so I need an equation. So I'm going to multiply the concentration times the volume. Well, 0% is just 0. 0 times X is going to be 0, and over here I'm going to take 0.05, because that's 5% as a decimal, times this 800 minus X, and those two things together are going to be my total, my 2% times 800. Alright, let's give myself some room and let's steal this equation and paste it on the other page. All right. Five percent of 800. The 5 times 840, so 0.05 times 800. Yeah, 40. All right. Minus 0.05x, and 2% of 800, 16. 16 minus 40, negative 24, divided by negative 0.05, 480. All right. So this lab technician needs to add 480 milliliters of pure water to the 5% solution. Some type of a sentence that says that. All right. Our next problem. How much 20% dye solution should be mixed with 2 gallons of a 50% dye solution to obtain a 40% dye solution? So let's steal a picture to help us. And I'm wanting to obtain this 40% dye solution by mixing together a 20% solution and a 50% solution. So that 20% is diluting the 50 to get to 40, or you could think of it, the 50% is increasing the concentration of 20 to bring it up to 40. So I don't have any contradictions, with that. Let's see. How much of the 20% solution, so let's call that X, we're working in gallons, so let's make it X gallons, should be mixed with 2 gallons of this 50% to create this 40%. Well, if we have X gallons and we pour it into a container and we pour in 2 more gallons, then we have a total of X plus 2 gallons. So the pictures always help me understand it a little bit better. If they don't help you, then you can figure out some other way to help visualize the problem. 20% as a decimal number is 0.2, and I'm adding in order to equal, so I'm adding this 50% times 2, well, half of 2 gallons, that guy's going to be 1, and 40% of this quantity, X plus 2. So again, let's take this equation and copy it to another page just to give ourselves some more room. Point to X, like I say, half of 2 is 1. 0.4x plus 0.8. Alright, let's take away 0.2x from each side. Let's take away 0.8 from each side. And I'm getting that x is equal to 1. So 1 gallon. So what was it again? We have to add 1 gallon of the 20%. We add 1 gallon of this 20% dye solution to the 50% solution. Some type of a summary like that. Just some short little sentence of you must, if you can read my writing, add 1 gallon of, gosh, I forgot what it was, the 20%, yeah, the 20% dye solution to the 50% dye solution. So it doesn't have to be very wordy, just a short little summary. Alright. An eye wash holds 5 liters of fluid. It has been incorrectly filled with 5% saline solution. How much of the solution should be drained and replaced with pure water so that the resulting solution is 3% saline? So that's my fixed container type of situation. My radiator type of problem. So we imagine this being our container, and so this container holds 5 liters, and right now it has 5% saline solution, and we're going to drain some of this saline solution out of there. And we don't know how much we're draining out of there because it says how much solution should be drained. We know that we're in units of liters. So if we take out X liters, the water level or the level of fluid in there drops. So then we come along and we add into the inlet hole to fill it back up. So what we drain out lowers the water level. What we put back in raises, I shouldn't say water level, liquid level. And so what we drain out, the volume, is the same volume that we put back into it. But that changes the concentration. So what do we have? Originally we're starting out with a 5% saline solution, and that 5% saline solution is 5 liters. You're draining X liters of this 5% solution. We've got this 5% solution times X. We're going to refill it, and we're refilling it to weaken it. So how much with pure water? So the concentration of the pure water is 0. But I like to put in there just for visualization. I drain, then I replace, and now instead of 5%, the concentration is 3%. But when we filled it back up with water, it diluted it from that 5 to that 3. But we're back up to full capacity, a 5-liter container. So okay, so visually to me that's what's going on. The band is playing outside, and I don't know if you could hear it on the microphone. It was a loud thud, and I just about jumped out of the chair. About gave me a heart attack. Recorded on tape. That'd be embarrassing. All right. Now, let's solve this for X. I'm going to move my decimal point over because sometimes when I multiply by decimals, I accidentally. So if I multiply every term in this equation by 100, I have 5 times 5 minus 5 times X. The 0 is just 0. And then I have 3 times 15. That way I'm not going to remember, everybody laughs at me, but I'm serious that in mathematics, basic arithmetic is my weakness, but the problem solving, the application problem solving like this is what I really have fun with. All right, 25 minus 5x is equal to 15, or that minus 5x there if I subtract 25, and so x is equal to 2. So if we drain 2 liters from this eye wash and then refill it with 2 liters of pure water, we'll get the concentration that we want. So some type of a short summary, something, and I am not an English expert, so hopefully most of the time the sentences, my emails don't make a lot of sense to people because my writing skills are so bad. Drain 2 liters from the eye wash. Okay, well that makes sense to me. Or eye wash, yeah, eye wash container. And refill it. With the 2 liters. That says with 2 liters of pure water. So I'm sure that your little sentence, your little summary will make more sense than anything that I would write, because I avoided any kind of tests in college that had essay type questions unless it was like a lab related to engineering, or you're describing mathematical equations, or you're describing some process and stuff. Let's move on. Carl is going to make some trail mix by combining peanuts worth $3 a pound, M&Ms worth $4 a pound, and raisins worth $2.50 per pound. If he wants to have the same amount of raisins as M&Ms, how much should he have of each to create a 2-pound mix worth $3.10 per pound. So here's Carl's final mix. Carl's trail mix. And the cost is $3.10 per pound. And how many pounds does he want to make? A 2-pound mixture. Now, he did that with these ingredients. He had these 3 ingredients. And he can't lose money, so he's got to know how much his ingredients cost. So to figure out his price and everything. So what does he have? M&Ms, raisins. Oh, I forgot the peanuts. Well, the order doesn't matter, so I'll put it over here. The peanuts. All right, the M&Ms are $4 per pound. The raisins are $2.50 per pound. And the peanuts up at the top, the one I accidentally skipped, $3 a pound. Now, we need to think about, we know that the weight of all these 3 ingredients have to add up to 2 pounds. Now, he wants to have the same amount of raisins as M&Ms. So let's say he has X pounds of M&Ms, therefore he has X pounds of raisins. So it doesn't tell me about the peanuts, but remember the total is the sum of the parts. So we know that this Carl's mixture is 2 pounds. Part of it's M&Ms, part of it's raisins, and part of it's peanuts. So if you take this 2 pounds and you remove all the M&Ms, and then you remove the weight of the raisins, all you're going to have left is the weight of the peanuts. So the 2 minus x, hey, 2 minus 2x, that's got to be the pounds of peanuts. So as soon as we know the number for the weight of the M&Ms, we'll know the other two. Now, just like before, when we took the concentration times the volume, we're going to take this cost per unit times the number of units, So when you do that, the pounds cancel, and all of these terms represent dollars. You want to make sure that when you're adding things, that you're adding dollars to get total dollars. You can't add dollars to pounds and get any kind of meaningful result. So you've probably learned that from your chemistry class. I think that was the first place that they really got me thinking about the proper units of things. It wasn't actually a math class, it was that chemistry class. And then, of course, I applied it to all of my math classes. So I've got 2 times this 310. I've got 4x, and I've got 2.5x, and I've got 3 times this 2 minus 2x. So now you're going to be fantastic at solving the equation once you get it set up properly, And that's the most difficult thing in the word problems is the setup. It's not solving the equation. You've been doing that fine. By the time you get to the equation, sometimes everybody's been chewing their fingernails and stuff or pulling their hair. But all right, so $6.20 and 650x. I delete the 0, I guess. And 6 minus 6x dollars. All right, so what do we have? If we take away the $6 from each side, the 20 cents, the 6.5x dollars minus 6x dollars, 0.5x dollars. So that's 1/2. If I double both sides of this, 0.40. Or in other words, if we're working in pounds, 4/10ths of a pound is 2/5 of a pound. And then, so I had 2/5 of a pound here, 2/5 of a pound of raisins, and so let's write out what I have in some type of a short little sentence, hopefully making sense. All right, so we've got, I guess it doesn't matter which, I changed it doesn't matter which I list first. So Carl's trail mix, Carl's trail mix. You use 2/5 of a pound. Gosh, I forget what the M&Ms and raisins. Yeah, 2/5 pounds of M&Ms, 2/5 pounds of what was it? Raisins. Yep, raisins. Now that's 4/5, so 2 minus the 4/5 is 1 1/5. So 1 1/5 pound of peanuts. Use that to make Carl's delicious trail mix, to make the trail mix. Some type of a short little sentence summary. All right, and really, you want to make sure that your numbers include units and identify the different parts of the problem. Okay. How many pounds of chocolate-covered peanuts worth $5 a pound should be mixed with 5 pounds of chocolate-covered almonds worth $8 a pound to form a mixture worth $6 a pound? So here's my final mixture that is $6 per pound. Its ingredients are chocolate covered peanuts, worth $5 a pound, and you have these chocolate almonds, and they're worth $8 a pound. Alright, so how many pounds of chocolate covered peanuts? So when it says how many pounds of chocolate covered peanuts, there's my variable. I'm going to let X be the pounds of chocolate covered peanuts. I've got 5 pounds of chocolate covered almonds. So if I'm adding them together, I have X plus 5 pounds of this mix. Okay. So we take, when it was concentration, we took concentration times volume, and here we take this unit cost times the unit. You can see dollars per pound, that the pounds cancel when you multiply it. So this term has units of dollars, and this term has units of dollars, and 8 times 5, that has units of dollars. So we've got 6x plus 30, and we can see that we're going to get x is 10. Subtract 5x, subtract 30, x is 10. 10 pounds of chocolate covered peanuts are used to create this mix. So some type of just a short summary, add 10 pounds of chocolate covered. How do you spell chocolate? Yeah. Chocolate covered peanuts to the chocolate covered almonds. Boy, my handwriting's terrible on this. That's my answer. Alright. When making a cake, a chef combines flour and sugar together. The 5-cup mixture is supposed to be 30% sugar. Unfortunately, the chef was distracted and added equal amounts of sugar and flour. How much of the 50% solution, it's 50% because he added equal, the whole thing is half of one thing and half of the other. So how much of the 50% solution must be removed and replaced with pure flour to create 5 cups with the correct mix? Alright, so again, that's like my radiator problem. We've got this original radiator, this original container, and the original container is 50%. He wanted 50% sugar. He wanted 30%. So, and it's 5 cups. So he's going to scoop out and remove some of this 50%. And we got to figure out how much. So now when you remove, the container now contains less than 5 cups. Well, you fill it back up with X cups. And we're wanting to dilute the sugar concentration by adding, did it say pure flour? Am I reading that right, 5? The pure flour. Well, pure flour shouldn't contain any sugar. My concentration is of sugar, and pure flour, I can't speak, pure flour has no sugar in it. So that's going to dilute that 50% to where when we add the X cups back in, we're back up to 5 cups. But now, by adding the flour that had no sugar, it brings the sugar concentration down from 50 to 30. That's the idea here. You're subtracting, you're draining away from the container, or in this case not draining liquid, but you're scooping it out, and then you're replacing it with scoops of flour. So just as before, we take concentration times the volume. I'm going to put my concentration in terms of decimals, and that's out of habit. Like you saw on that one problem, I moved it back there. I could work in without moving the decimal too. It's just in other problems you'll want to get in the habit of moving that decimal point over 2 places. So I've got 0.5 times 5 minus 0.5 times x, and the 0 times x, I don't have to write it in. I usually just do to help me visualize the equation and double checking that I haven't made any kind of silly mistake. Alright, so like before, like I said, I sometimes mess up with decimal numbers. If I multiply all these terms by 10, I get 5 times 5, I get minus 5x, I get 3 times 5, and now I won't make any stupid, decimal error in my multiplication and moving the decimal over to the right position and the right number of times and all that. 25 minus 5x, 15, subtract, I get 2. Didn't we have 2 before? Alright, so somewhat kind of sentence, the Chef Boyardee. The chef, or is that chef or is that chief? No, I guess chief would have an I in it. The chef. Wasn't there a Redskins commercial where the guy was painting in the end zone, instead of putting the Chiefs, he put chefs? I think that was an old commercial that I always thought was kind of funny. So the chef needs to remove 2 cups. It's like a Snickers commercial or something like that. It was probably on YouTube. Remove 2 cups of the 50% mix. Uh-oh, it's late in the evening and I hear the door opening, so I might have to pause this. Yeah, I'm going to, because otherwise they'll hear me talking. I'll be right back. Alright, they were making fun of me, Tommy was, for still being here. And I was like, hey, I'm dedicated, helping my students. Alright. We got talking and now I forget what I was doing. The chef. Yeah, the chef needs to remove 2 cups of the 50% mix in order to get that 30% and replace it. Like it's a drain and replace. So 50% and replace, I don't know, I forget now, replace it with 2 cups. Is that what we got? Yeah, the 2 right here. There's my answer, my 2. So, and replace it with 2 cups of flour. Flour of pure flour. Alright, so some type of a brief summary that includes the units, that illustrates that you understand what you just solved for. That's all really what they're wanting. A piñata that holds 40 ounces is going to be filled for a child's birthday party. I think I've seen this on YouTube. Toy trinkets cost $1.25 an ounce, and candy mix costs 50 cents an ounce. How much of each should be used so that the cost to fill the piñata is $30? Alright. So we've got our piñata mix. I'm not going to draw some crazy picture that's a piñata, but this is a total. We know the ingredients that the piñata contains. What does it contains? The toys, the toy trinkets, and I guess I could have been using my diagrams that I drew up before the video, but I'll just sketch it. I like doing it. Candy. Alright. Now, our units are an ounce, so the toys are $1.25 an ounce, and the candy 50 cents per ounce. Alright. The piñata holds 40 ounces. And we want that piñata to be a $30 piñata. So it's really not $30 per ounce. So whatever the total, when I do this product, it's going to be, the cost to fill the piñata is $30. So down here is 30, because let's see how much of each should be used. We've got 40 ounces. So if this is 40 ounces, and if I let X be my toy, then remember, if the 40 is the total and I remove all the ounces of toys, what I have left is the ounces of candy. So if I have this total and I remove one part, what I have left is the other part. Or in other words, when you add these together, those X's have to cancel so that you get 40 ounces. So the $30, whatever this is in terms of dollar per ounce, it's telling us in the wording of the problem that when you multiply it by 40 ounces, they want a $30 piñata. So let's come over and go 1.25 times X. Let's go 0.5 times 40 minus X, and let's solve this equation. So I'm going to move this equation to give myself a little bit of more room. Alright. So one equation, one unknown, It's not even quadratic, it's a linear equation. Pretty easy to solve if we don't make any silly arithmetic errors. If we take half of 40, we get 20 and distribute that. So if we take away 20 from each side, we've got 10. If we take away 50 cents from $1.25, 75. And if we divide, if we have 10 divided by 0.75, 13 1/3. So let's look back. The 13 1/3 ounces of the toy trinkets. So this was ounces of toy trinkets, and the 40 minus x no, 20. Okay, stop yelling at the screen saying he's an idiot. That 1/3 and 2/3 is a whole, and this guy is 39 plus the whole is 40. So I have the 13 1/3 ounces of toys, 26 2/3 ounces of candy, and write some type of a short little sentence, some type of fill the pinata with 26 2/3 candy and 13 1/3 ounces of toy trinkets. I wonder how they came up with the word trinket. A floor cleaner is made by mixing water and ammonia. How much 10% ammonia mixture should be mixed with a 1% ammonia mixture to form 1 gallon of a 3% ammonia mixture? So I have 1 gallon of a 3% ammonia mixture that I made by mixing water and ammonia. No. How much 10% ammonia mixture? 10%. How much x gallons should be made with 1%? So the water that they're talking about was already used to 1%. And this is 1 minus x gallons. So let's see if logically, if by adding 10% to 1%, you're increasing that concentration of 1%, but to how much? That 1% increases to 3. Or if you look at it, I've got this 10. The 1% is going to dilute that 10 because it's less all the way down to 3. So the final mixture the percent concentration has to be between these two concentrations. So I don't have any kind of a contradiction here. So if I move this decimal point over, I've got 0.03 times 1. If I move this decimal point over, 0.10 times x. Now, this guy, 1%, remember that's 0.01, because the 0.1, you moved it over. When you move it over 2 places, when it's a single digit there, you need that leading 0. All right. And again, I'm embarrassed to say it, but like I say, I'm so used to being embarrassed it doesn't matter anymore. If I multiply everybody by 100, we have 10x, 1. So what do we have here? If I subtract 1 from each side, if I subtract x from 10x, and if I divide 2/9 of a gallon, okay, so this 10% is 2/9 of a gallon, and this 1% is going to be 7/9 of a gallon to add together to form the 1 gallon, right? So some type of a summary, add 2/9 gallon of this 10% ammonia to the 1% ammonia concentration. All right. Hey, that was it, I think. Was that it, or did we have 10 problems? I think that's it. So, hey, I hope this helps, and I'll even post it early over the weekend to see if people will take a watch at it. Take a look at it. I'm not making any sense. Bye.